Thank you. Hi guys, thank you for coming after the lunch. It's a pleasure to be here. My name is Igor Barinov. I work in the Ethereum space for a while, known as a ex-founder of ETHTaipei, which is now Gnosis chain, and supporter of Block Scout, which is the mostly used EVM block explorer, used on more than 200 networks, like on all EVM ecosystems. Also, I'm proud that back in days in 2018, we launched the first EVM to EVM bridge in production. So that was the first EVM bridge. And for a couple of years, supported two core execution layer clients, which was Open Ethereum and Mana client. Both of them are not working anymore, but that's how I got into this, right? So for now, I'm working on zkBob, which is a way to send tokens on-chain privately. And we think that this is one of the most important use cases for crypto. And if we remember back in history, when like Satoshi announced Bitcoin white paper, it was like electronic peer-to-peer cash system, right? I think the missing piece was privacy. So what is zkBob? So zkBob contains like three parts. So one is Bob, which is a stable token. I'm a big fan of inclusive things, like things which are like easy to mint or they have advantages and some like capital efficiency and so on. So Bob is multi-chain, multi-collateral with what we think is the cheapest supply side on the stablecoin side. To make this stablecoin unique, like 2 years ago, we started to work with Zero Pool team. We started to work on the privacy layer for the stablecoin transfers. And the idea was, how can we make this stablecoin with kind of account abstraction? Back in days, we didn't have this term widely used. So second is how to make it with meta transaction, gasless, how to make it private and work on layer 2s and make it cheap for users to transact tokens, right? To mint this stablecoin, the like most common way is to like liquidate one asset, like whenever asset is traded on like Uniswap or using DEX aggregator to the Bob token, or to use like upcoming this CDP model, which is kind of similar to other CDP models in different collateral-based systems, right? So the idea of the stablecoin is that it's built on the model of concentrated liquidity, which was introduced in Uniswap v3. So as you might know, in Uniswap v3, you can create LP pair with only one token, and the second token will be as an option for buyers to buy by selling their assets through some rounding pair, right? So we use this concept to basically create a way how like users can like buy this new stable token with any assets which is tradable on Uniswap, right? So the supply side is basically the cheapest one on other stable coins, right? So the idea here is that to make stablecoin more kind of keep it like when you make a stablecoin, the idea is you have to peg it to something, right? And it's very hard to peg just to $1. So usually it's some form of other stablecoins. In the current world, like in 2023, it's basically USDC or USDT, right? So the model of Bob stable token is like more aligned to USDC, which had some problems recently, but we think that it's kind of making our industry better, and some ideas like what is introduced in PSM model, which we have a kind of analog in stable token, which we call Bob swap. It's a way of swapping stable coins between within the pair with a fixed rate. And this fixed rate can be adjusted to market price of USDC. That's kind of what we learned during this USDC DPEC, right? So the stablecoin itself is very capital efficient. It's deployed on mainnet and several layer 2s. And soon coming to other chains, we have proposals to deploy on Gnosis chain and some other chains which people want to see. So now we know that Bob is a stablecoin, efficient, deployed on multiple chains, multi-collateral, over-collateralized, and so on. Like, what is zkBob, right? And this part is what is intriguing me the most about the adoption of the stablecoin is because we can send transactions on chain with using zero-knowledge technology. For now, it's deployed on Optimism and Polygon. So the main features are quite simple, right? But when I think about simplicity, like what is actually people need, I think what most of us in most interactions on public blockchains, we need to have an ability to transfer some funds, right? And maybe withdraw from some instruments where we have our funds locked, right? Maybe some staking contracts and so on, right? So usually when you use privacy pools, there's like a way to deposit funds, withdraw funds. At that point, when we do it on public blockchains, identity of wallets which are depositing or withdrawing are revealed. But when we transfer within the privacy pool, the transaction is not revealing information about source, destination, and the amount sent within the privacy pool, which is giving us full on-chain privacy without the need to use gas token, without the need to send directly transaction, and so on. So as you can see, the application itself is quite simple, and all like zk parts are hidden behind the commonly used interface where we have like deposits, transfers, and what is making zkBob special that also we have a way to send multi-transfers. So in one transaction on chain, a user Alice can send up to like 127 transactions within the privacy pool. zkBob is based on UTXO model, so that's basically creating 127 outputs in one transaction. And if we have multiple, if we need to send more, like a bigger airdrop, then multiple transactions will be submitted by a relayer. And this is like all mechanics behind this is hidden from the user. They just post zk addresses, amounts, and use interface similar from other multi-sender tools like multi-sender or others, right? So, but this, I think from my point of view, is the first zk multi-sender. For now, it can send Bob token, but starting next month, we'll be able to send ETH, OP token, and some other tokens on other networks, right? I think that inclusiveness is very important, UX and inclusiveness. Like, we should allow people to use crypto on their like regular devices without kind of need to install any additional software. And zkBob is working on your mobile devices. You don't need to have any wallets. If you have a wallet like any Ethereum compatible wallet, you can create an account in zkBob by signing a message within this wallet. But if you don't, you can sign up with a seed phrase. Can be like a burner type of seed phrase or a permanent one. And this is encrypted within the local storage, right? Which is sometimes it's concerning, but for inclusive use cases, it's fine, right? So zkBob is working on mobile devices in a browser. Transactions can be sent without signing any transactions, and all abstraction of account and gas is hidden by sequencer, which is including transactions into UTXO or in public contracts on top of Optimism or Polygon, right? So we had some challenges here to make it optimized for like multi-thread computation within the browser tab, and that's actually quite impressive that we can have proof generation around 15 seconds in a browser on a regular iPhone 14. Unlike older models, it takes up to like 1 minute, but it's still doable if people need to send or receive amounts, right? So use cases for peer-to-peer cash is like massive use case, right? So I think transfers is the most important one, right? When you need to send or receive transfers. We use ourselves zkBob to send all salaries and bonuses and like everything we have within zkBob and Black Scout. Our 35 people right now. We're sending it basically every week. Sponsoring hackathons, sometimes giving prizes and so on. So this like use cases for zk payment layer, I think, is like the most widely used use cases. As one Bitcoin maximalist said back in days, people will try all different use cases of blockchain technology, but peer-to-peer transfers are like the most important, right? And we can see it by volumes on any explorer. So just like a few words how it works for me. Let's say I'm a Carl and I need to pay salary for my kind of employees. So I have some USDC in treasury. Why USDC, not Bob? Because USDC is kind of yield generating asset, right? So I can keep it within my treasury. And when it's a payday and I need to pay salary, so I convert a chunk of this treasury into Bob stable tokens, deposit into a privacy pool. And within the privacy pool, I can send one transaction to distribute to multiple zk addresses of employees. And I already, as an employer, I know these addresses, right? Each employee receives it in their own. For like all employees, it's like one transaction from Carl's side to all employees. For each employee, they can withdraw a part or the full amount, or they can send to other accounts and so on, right? Ideally, in the future, we expect that more people will use privacy transfers within privacy pools, so they will not need to exit into public blockchains. But unfortunately, it's not always possible because integration is quite hard, right? So when Alice, Bob, Chad, and other guys receive salary and they exit from the privacy pool, they can use LeFi integration, which is a bridge aggregator, and exit on the. Because it's a bridge aggregator, it aggregates all rates from different bridges and exit to any chain they want. It's at the cheapest rate they can get, right? So this workflow works pretty well, and I'm quite happy that in 2023 we can have like really working cycles of like business transactions happening within privacy pools, like when users calculating snarks on their devices, right? When like account managers who are paying payrolls calculating snarks on their devices, right? When people using this underlying technology and they don't care like how it's implemented at the infrastructure level, right? But we can have this, and as Vitalik said yesterday, privacy is happening, right? But here is a sour part, right? Compliance. So, why privacy is happening? So first of all, because we have more and more, proving systems. We have recursive snarks. We have like more projects. We have more people educated within zk, and so on, right? But it's quite hard to build projects which are actually foresting and facilitating privacy, and grow it without having this, uncertainty about the future. So the biggest concern for many people was the situation with Tornado Cash, right, and the problem with like founders and all the sanctions and so on. So many projects started to think about like compliance and like what we can do better. But let's talk about like challenges of privacy in the blockchain. Like, well, by default, like how systems were designed and how like we started to like work in the space back in days, privacy was hard to achieve, right? So that's why the current blockchain architectures usually they promote transaction transparency. But we think that this like lack of privacy is actually making a lot of problems for adoption of public blockchains for many use cases. So one of the cases, like why don't we have CBDCs on top of public blockchains? It's because governments cannot do it in a transparent way, right? So that's why they have to use side chains hidden within their private infrastructure and so on, right? Many businesses are not able to share data between them, right? Many business practices like auctions are built on the idea that you have privacy for this type of transaction, right? So zk proofs are a good solution, right? Because cryptography allows us to enable privacy, and also it was challenged to build real-world products, because sometimes you can build something in console, but after you understand that people want to use it in the browser, but after you understand that people want to use it in the mobile browser, and so on, right? So to build working products was challenging, but also on the other hand, it's challenging that when we build it for like inclusive use cases, we also see that a lot of use cases which we don't want to see can appear, and there are actually not that many ways to do anything with them if you don't put any restrictions to make these use cases less attractive to bad actors, right? So, like, that's what I think, and what's also ChatGPT thinks about. Like, why do we need privacy? I asked her, like, what are your arguments for privacy? And I think that the argument of encouraging adoption is something that we're missing a lot when we think about privacy tools. That like many use cases and people really need to use private tools to make them worth to switch to public blockchains and so on, right? But also definitely there are some arguments against the privacy, right? And I think the regulatory concerns, which are basically because they cannot scan and observe all the data on chain, are quite important, right? Technical challenges, luckily we have a lot of researchers and tooling and like auditors right now, which are kind of helping us to build these tools. But balancing between privacy and transparency is something hard, right? So recently there was an article by A16Z, which was which was based on the paper, like which type of solutions we can enable in decentralized application to actually make it more regulatory compliant, how to say, right? And I think it's when we trying to make categories out of those ideas, right? It's all about same things, right? How can we make screening to actually prevent bad actors to deposit funds into those pools, right? How can we do like screening on withdrawals? Well, ideally with some trace of transactions to prove that like the chain of custody doesn't contain any bad actors' capital, and how to make selective de-anonymization, which is sometimes it's hard in some models, like in the UTXO model, it's quite hard. So basically, a user can provide a way to regulators to de-anonymize part of his transaction trail. In some tools, it's easier. Let's say in Tornado Cash, where it's based on nodes, users can disclose each node individually. But when you have like a trail of deposits and withdrawals in UTXO model, it's more complicated, right? So we think that the approach for the next generation of privacy tools is to find the balance between decentralization and compliance, right? So for sure, as people long time in this industry, we want to make tools for crypto native people, make it in cyberpunk point of view, right, where it's like fully trustless, fully decentralized, and so on. But in reality, we can find the balance. And when we think about this type of balance, it's actually quite interesting that we can reinvent some of the practices, like KYC practice, and I will show a case in one example very soon. So screening is important, and when you think about screening, it's already used in many decentralized applications. For example, 1inch, right, which is the leading DEX aggregator on most blockchains. They're using TRM screening, not only for users, but also for solvers who are closing limit orders for users, right? So their new model is based on limit orders, and so first of all, users screened on TRM Labs integration, and after solvers who are making transactions for users are also screened, right? But for most of us and for most users, it doesn't They don't see it, right? So Ethereum integration is what is doing on the so what we do on the sequencer side. There are some challenges how to make this type of integration in a decentralized way when you need to rotate sequencing, and there are some ways how this can be ensured with proofs of inclusion of specific address into Ethereum Labs database can be embedded into some Merkle proof, and on each transaction, decentralized sequencer can basically check this proof for inclusion and make it on-chain. So on relatively cheap rollups and chains, that can be done in a decentralized way, right? So some other tools which we built inside zkBob, and I think they can help in many situations. If you remember Daplion's presentation from yesterday, he mentioned OmniBridge and XDAI bridge from Gnosis chain, and he mentioned that they were never been hacked. And one of the ideas that was implemented in this bridge was about limits, that each possible problem with security of decentralized app should be mitigated in some way, right? So we think that limits are a very important way to mitigate risks. So for zkBob, limits of pool size and how many tokens can be deposited and withdrawn by different tiers and so on. That's all defined by the governance process, and that's something that most privacy pools should adopt, right? Because if privacy pool is quite small for bad actors to deposit funds, or they can hit daily limits, very likely they will look for some other tools, and unlikely they will kind of put a lot of, if you remember, Harmony Bridge and some other bridge hacks, when a lot of capital flown into one privacy pool in a matter of hours, right? So KYC, I think that's now it's a great time to redefine what KYC is. We're working with one project which is abbreviation is KYC, but they call themselves Know Your Cat. So Know Your Cat is by Opium team. So the idea here is that Know Your Cat is a soul-bound NFT. So this NFT can contain trades from on-chain KYC done by other providers. For example, in this scenario, zkBob this cat has a trade from Binance called Binance Bob BAB, and the trades proves that the owner of this address is not a U.S. person, right? And if it's not a U.S. person, we can give some additional limits within the privacy pool, which is important for geo restrictions, right? To split users into different cohorts and give different limits or different UIs to different cohorts of users, right? And what is interesting about this Know Your Cat thing is that it's using byproducts of other KYC providers, right? So we don't need to do KYC ourselves. We don't have any UI for KYC, right? But when users have the self-bound NFT on their deposit account, they get additional perks, they get additional limits, which is the way how composability should work into compliance, you know? Selective de-anonymization, I think that's very important for the future parts of the development. That's what we plan to focus and actually, I think, provide some ideas for other protocols which will use UTXO model. One of the our latest feature, I think what is most privacy protocols are missing is composability. Why Ethereum is so popular? I think one of the killer feature of Ethereum is composability, right? Because contracts can call other contracts. But when you think about zk apps, one zk app can call another zk app, we don't have such protocols, right? And even if we have, it's kind of built within one team or within one ecosystem. Like in Aztec, it was kind of like that, right? But when we think about how can I integrate my, for example, DEX protocol or bridge or some open source wallet and so on into privacy pool, how users can deposit into privacy pool, usually there is no way to call a contract and kind of make a proof for a user, right? So usually these direct deposits, they decrease anonymity of users because in our case, when there is a direct deposit and we need to send the zk address on chain that disclose a little bit about the user, But for many use cases like payroll, it's very important to have this composability. Okay, so time is up. I have POP. If you mean this POP, and send me a picture here, I will send you $100 each. Okay, so my Telegram is on right. So this is POP. We have like 58 POPs. So just, you can Telegram me Igor Barinov or by QR code later on. Or you can find me, usually if you install zkBob app and yeah. So my time is up. I don't know, if you have any questions, please ask. If don't, please grab some POPs and exchange them for $100 later on. Questions? Questions. One question. Give me one question, please.
Okay.
Okay.
Let me ask one question. Because I saw you in your slide, you have a ZK address. So I guess maybe you have two different accounts. One is EOA and the other is maybe share account or something. Is it correct in your application?
Yeah, well, ZK address, you generate ZK address for each transaction, but it's all generated deterministically from your ZK account. So if you disclose it, it's not a problem, right? So you can generate it as much as you want, basically like a Bitcoin model, right?
Okay.
So, cool. Thank you very much, guys. Bye-bye.
Thank you.